So once again, welcome you back to teptalks.com, and we are going to proceed with our as usual episode which we are on. Now we are going to go to the branch of the nature of roots of a quadratic equation. So I want to look at the nature of the quadratic equations. So for the equation of the form ax squared plus bx plus c equals 0. For this case, we are looking at when a is not equal to what? To 0. Because we said that when a is equal to 0, the whole equation becomes linear. So that's why we are saying that when a is not equal to 0, for this form, we are talking about quadratic equation. The equation of this form, where a is not equal to 0, is termed as a quadratic equation, and x equals negative b plus or minus root of b squared minus 4ac all over 2a is, as we proved the other time, is the quadratic formula. I want to look at that. And b squared minus 4ac, the one which is here, is called the discriminant and is used to determine nature of the roots, and is used to determine the nature of the roots. So this b squared minus 4ac is the one which will tell you that the root is imaginary, or either the root is repeated, or either the root is different from them, as you are going to be looking at them. So when you are given this kind of a formula, as you have been doing it, and you come out with b squared minus 4ac, it will give you the nature to tell if the is real or if the root is imaginary or has got repeated roots, as we are going to be looking at them one by one. So I'll start with the case 1. If b squared minus 4ac equals 0. If we find that in your calculation that b squared, like this scenario here of this equation, that b squared minus 4 times a and c, all of them are equal to 0, or b squared is equal to 4ac, that one is called a real root and has got repeated roots. Is a real root and has repeated roots. As we are going to be looking at those examples which are following with it. When you talk about a repeated root, that if you happen to plot your graph, a graph, for example, if y equals ax squared plus bx plus c equals 0, and you happen to plot your graph on a Cartesian plane, this is a quadratic curve which has got a positive gradient. So, and this is our y-axis and this is our x-axis. You happen to plot this curve, come like this, and this is our maximum point here. This is where it tells you that where it is cutting, and you are saying that y equals ax squared plus bx plus c. So if you happen to come out with that, it means it has got all the values which are there are repeated, because when it comes here, it is repeating and it is going back, and it has got all of them what you call their real values. That's why you can see they are not changing to be in a different direction of that. For example, example 1, given that 8x squared minus 8x plus b equals 0 has repeated roots, find the value of p. So if a question comes in that way, what you do, you can see that what you have is already a quadratic equation. Let's look at the solution. You start by saying comparing 8x squared minus 8x plus p equals 0 with ax squared plus bx plus c equals 0. So if we try to compare, so we are going to look at the coefficients of x squared and we compare them, also the coefficient of x and the coefficient of x power 0. So we are going to be comparing them and we see what likely is going to come out from our expression here. When we try to compare, it implies that a equals 8, b, you can see b equals negative 8, and c equals p. But they have said that this equation has got what we call repeated roots. What do we know about for repeated roots? Or for it to become repeated roots, automatically it has got what we call, it is a real root. And we use our expression, we say, for real roots, b squared minus 4ac equals 0. If you don't want to say maybe 4ac equals 0, you can even first take that one. You say b squared equals 4ac. Then from there, we are free to substitute in our required. We have already got, what is our b? Our b is already negative 8. Substituting, we say negative 8, the whole of it squared, minus 4 into, what is the value of a? A is already 8. What is c? Is already p. The whole thing equals there. So we go ahead. Negative 8 squared, you get 64, minus 4 times 8, you are coming out with 32, times a p, it will be 32p. 32p. Then you can now collect like terms. This one is a negative. When it goes that side, it becomes a positive. What is happening? We get 64 equals 32p. On both sides, divides out by 32. Divided by 32 by 32. What is p? P equals 2. You would have already come out with the value of p if they have given you a condition that x, or the equation has got what we call repeated roots. So we are proceeding to example 2. Example 2. If x squared minus x plus 1 all over x plus 1 equals k as repeated roots, comma, find the value of k. Full stop condition. What are the repeated roots? What are the repeated roots? So they have given us a question which is in that nature, and they have said that the whole of that one is equal to, and they have said it has got repeated roots. What do you do when a question comes into that manner? Solution. So I've got x squared minus x plus 1 all over x plus 1 equals k. So the first step is we are going to cross multiplication, and we'll arrange it in terms of ax squared plus bx plus c equals 0. So can we cross multiply? We are going to have x squared minus x plus 1 equals k into xc plus 1. So can we go ahead and open the brackets? We are going to have x squared minus x plus 1 minus, can bring this one, k into x plus 1, the whole thing equals 0. So can we open the brackets and we bring the stuffs together? X squared minus x minus k, you can say minus kx because we are pushing in, minus a k, then plus a 1 equals a 0. So we factor out here and a value of x. So we are going to have x squared minus into 1 plus k into x, and plus this is the same as 1 minus k equals what? 0. You can see now it is x squared, it is now in form of ax plus b. Then it's not so from there say comparing with ax squared plus bx plus c equals 0. So we are going to compare those stuffs. What is our a? A equals 1. What is b? B is negative into 1 plus k. What is a c? C equals 1 minus k. That is the value of c. Then, what do we know about, they have said for repeated roots. Then we say, for repeated roots, b squared minus 4ac equals a c. That's why I said that you first see the nature of that discriminant. Is it a euro? Is it bringing a repeated roots? And if it is for repeated roots, then we are free to go ahead and apply what is required. Then we say for repeated roots, this mathematics, I know I tell you, it is very interesting, so long as you are very keen and very serious. For repeated roots, b squared minus 4ac equals 0. So, can we substitute in what is our b? Our b is already negative into 1 plus k, the whole of it what? Squared, minus 4 into a is already 1, c, what is the value of c? Is into 1 minus k, the whole thing equals 0. So can we go from Pascal's triangle, like what we did behind, or from the expansion? So a negative crosses will remain with 1 plus a k, the whole of it squared, and go ahead minus 4 into 1 minus k equals 0. So from Pascal's triangle, when try to expand 1 plus k, it means 1 plus k is appearing 2 times. It is 1 plus k again into 1 plus k. And from that expansion, we shall come out with 1 plus 2k, then plus k squared, push in, minus 4. A negative times a negative, we say plus 4k equals 0. So can we rearrange it in terms from the highest to the smallest? So we are going to have k squared plus 6k, because 2k plus 4k, you're getting 6k, minus 1 minus 4 minus 3 equals 0. So, how do we solve this? Look at this, think of a number, think of two numbers. When you multiply them, you come out with a negative 3, and when you happen to add, you're going to come out with a positive 6. Are they there? If they are not there, that means you are free to use what you call completing square, or you are supposed to go ahead and use what we call quadratic formula. So any of that can arise. So I will use the quadratic formula from k equals negative b plus or minus root of b squared plus 4ac all over 2a. So can we substitute in k equals, what is our b? Is already negative 6. We say negative 6 plus or minus root of, that is 6 squared minus 4 times 1 times negative 3 all over 2 times 1. So what can we go ahead? This becomes negative 6 plus or minus root of 6 squared, you're getting 36. The negative, you're getting plus 12 all over 2. So go ahead, what is k? Negative 6 plus or minus 36 plus 12, we are getting root of 48 out of 2. So can we get k? This is negative 6 plus or minus root of, if we want to put it in terms of sides, can we use Sadiki ways? That is the same as plus or minus 16 times 3 all over 2. We got, this is k, negative 6 plus or minus, this is 4 root 3 out of 2. So 2 can divide every